Hello, in this step I will walk you through the physical hardware setup for acquiring wave signals from Guage and feeding them into the LabVIEW system using the NI USB 6363 data acquisition system. And we will see how each cable connector component plays a role in transferring wave information from the physical environment that we have here into a digital domain. So we will start with the wave gauge probe, which can be submerged or placed near the water surface in a wave tank or flume. In our case, we are using a cylindrical container with water filled. Our student used this setup to calibrate the sensor. This probe or the sensor senses water surface elevation and converts it into a corresponding analog voltage signal, usually in the range of 0 to 5 volts, depending on the calibration and water height. The output of this probe, as you can see, is connected via BNC cable to the Akamina 224.3. This is the one. And this Akamina unit conditions and amplify the signal to ensure it is stable and clean enough for digitalization. This Akamina 243 acts as an interface between the raw wave probe and the data acquisition system, DAQ, and it performances tasks like signal amplification, filtering to remove high frequency noise, proper grounding and protection. So this Akamina requires power to operate. So it has a power cable connected to the main supply, and it is via this orange box. Now that orange box. A bit messy here, but this orange box has 3 ports, one which is connected to the Akamina, this one, and the other 2 are for the power supply, this one which is connected to the adapter of 9 volt, and the BNC cable which is then gets connected to the data acquisition system, the NI 6363. Important to have to check if the lights in the Akamina setup are blinking correctly. We should see like there is a green light which should be always on, and there would be a red light blinking every 9 seconds. This one, yeah. So this is the BNC cable that comes from the orange box that I showed you before. It's behind the computer, this one, and it is connected to this DAQ device. And you should keep a note of the port it is connected to. Here it is connected to AI1 port of the DAQ device, and it also requires a power supply, and to check if it's working and the power supply is working well, there is a blue light. We should always see if it's on or not before preparing the LabVIEW, starting on the LabVIEW system. So it has a USB cable connected to it, and the output of this device is again connected to the computer. In summary, the wave probe detects the physical wave motion. This BNC cable carries the raw analog signal to the Akamina 224.3, and the BNC cable is connected to the orange box. BNC cable that is coming from the orange box is connected to the NI DAC device, which digitizes the analog voltage into a waveform that we will analyze in the computer. And and the data is transferred to the computer using a USB cable. And in the this is the most important part in the LabVIEW file. This is the DAQ assistant block that receives the waveform for processing and lodging the data. We will see like a brief sample or demonstration how the plot varies. It is actually the amplitude versus time plot, and how it changes with the change in height of the wave probe. In our original system, in this wave tank, the wave probe will be fixed, but the water level will be changing. But in our miniature setup, we are fixing the water level and changing the height of the wave probe. As you can see, like if I put it down, the value of the amplitude changes. So firstly, when it is like slightly dipped into the water, the value is within 0.8 and 0.9. You may not be able to see from the camera footage, but it is. But when I put deep into the water, the value should increase, and it is between 3.4 and 3.6, and maximum it will go in between 4.5 and 4.7. That is correct. And if we do some miniature waves or random waves in the water, we will see there is a variation in the plot as well. Along with this one, we have other two wave probes, capacitive wave probes like this. A student named Hugo performed calibration of all these sensors. Like he measured all the variation of the voltage with the depth, and for 3 times for each probe at different conditions, and he found that the wave probes are all working well and have consistent and data equation capabilities.